True projects. In this video, we are going to explain about cybersecurity named entity recognition using bidirectional long short-term memory with conditional random fields. Introduction. In the cybersecurity arena, the project focuses on the problem of named entity recognition (NER), which entails detecting entities with specified meaning in unstructured text such as person names, place names, institution names, proper nouns, and so on, to extract security related concepts and entities from unstructured text. The project presents a novel cybersecurity entity identification model based on bidirectional long short-term memory with conditional random fields by LSTM with CRF. The X by LSTM CRF model combines X input with bidirectional LSTM output and is composed of a word embedding layer, a bidirectional LSTM layer, and a CRF layer. The project shows the X by LSTM CRF produces improved cybersecurity entity extraction through extensive trials on an open source dataset containing an office security notice, security blocks, and the common vulnerabilities and exposures list. Objective. The project's goal is to offer a new cybersecurity entity identification model based on bidirectional long short-term memory with conditional random fields by LSTM with CRF for extracting security-related concepts and entities from unstructured text. The proposed X by LSTM CRF model intends to improve the problem of named entity recognition (NER) in the cybersecurity sector, which requires identifying entities with defined meaning in unstructured text. The project shows that X by LSTM CRF outperforms state-of-the-art cybersecurity entity extraction algorithms in comprehensive testing. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload Security Open Source Dataset. In this module, the project starts by obtaining a security-related open source dataset. This dataset likely contains text data that includes various cybersecurity-related information such as security reports, articles, or logs. The dataset is labeled, meaning that it should have annotations indicating the positions and types of named entities present in the text. Named entities in the text of cybersecurity includes things like IP addresses, domain names, malware names, vulnerability names, etc. Uploading this dataset is the first step in preparing the data for the named entity recognition (NER) task. Second module is pre-processed dataset. Once the security open source dataset is uploaded, it needs to be pre-processed to convert the raw text data into a format suitable for model training. Pre-processing steps includes tokenization, breaking text into individual words or subwords, lowercasing, removing special characters, and handling any data-specific quirks. Additionally, the data set is split into training and validation sets to assess the model's performance accurately. Third module is Build X by LSTM CRF model. The X by LSTM CRF model is a combination of bidirectional long short-term memory by LSTM and conditional random fields (CRF). By LSTM is a type of recurrent neural network (RNN) that allows information to flow both forward and backward through the network. This enables the model to capture dependencies in both direction in the text, making it well suited for sequence labeling tasks like NER. On the other hand, CRF is a probabilistic graphical model that takes the output of the by LSTM and considers the contextual information of neighboring entities to improve the overall NER performance. Fourth module is Precision Graph. In this module, the project likely involves training the X by LSTM CRF model on the pre-processed dataset. The model is then evaluated using various metrics including precision, recall, and F1 score. Precision measures the proportion of correctly predicted named entities among all entities predicted as positive. A precision graph shows how precision varies for different thresholds. That is, example confidence thresholds used during the evaluation. It helps to visualize the trade-off between precision and recall and to select the optimal threshold for the specific use case. Fifth module is upload test data and predict NER. In this final module, the project involves obtaining a separate test data set with cybersecurity related text data that does not overlap with the training data set. This test data set should also be labeled with named entity annotations. The X by LSTM CRF model trained in the previous step is then used to predict named entities on this test data set. The model proposes the test data and outputs predicted named entities along with their types. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. This dataset contains text in the form of sentences, and we pre-process all those sentences and then extract each word and assign associated class label. And after pre-processing, we will get this data set. So in above screen, values are separated with commas, where first word belongs to corpus data and second word is the NER label. We used above data set to train LSTM algorithm. This is the model folder. This folder contains pickle files stored, which contains algorithm information. These pickle files can be loaded into the project code during runtime to utilize the train models. This is the main code file. This is run.bat file. Instead of executing our project in the command line interface, we have created Windows bat file to execute the project. Now we'll click on run.bat file. This is the graphical user interface which we have created using Tkinter library in Python. By using this GUI, we will interact with the project. Click on Upload Security Open Source Dataset to upload the dataset. Dataset open. So in above screen, dataset is loaded and we can see dataset contains both words and associated NER, and this graph, x-axis represents NER name and y-axis represents count of words found in that NER. In above screen, we can see entire dataset is in string format and LSTM will accept only numeric data. So we need to pre-process dataset. By clicking on pre-process dataset, as this function will convert all string data into numeric data by assigning IDs to each word. So here we can see both words and NER labels are converted to numeric format, and now click on build X by LSTM CRF model to build NER model on above dataset and then calculate accuracy and precision on test data. So here we can see that we got the accuracy, precision, recall, F measure of X by LSTM. Now click on precision graph. So here we can see x-axis represents metric name and y-axis represents values of that metric. Now close the graph and click on upload test data and predict NER. So in above screen test.csv dataset, we can see we have only words, and after applying this words, LSTM will predict or recognize NER. In above screen, for each word LSTM predicted, it's recognized NER, and in first line word 7 has associated with hardware NER. Similarly, for each word we can see it's recognized NER. So here we can see operating system, entity, NER, 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 exit. The final conclusion of the project is the proposed X by LSTM CRF model outperforms state-of-the-art models in cybersecurity entity extraction. The project used an open source dataset and relabeled it for cybersecurity NER. The results show high precision and recall, making the model effective in identifying entities and security-related text of varying lengths. The findings will significantly benefit knowledge extraction and knowledge graph construction in the security domain. Future work would focus on extracting relationships from unstructured text, reducing the workload for security analysts. Constructing a security knowledge graph can aid in discovering connections between organizations and people, leading to better understanding of cybersecurity situations.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.